Okay, so question 1. The discrete random variable x has a probability distribution as defined in this table. So we are asked to find the probability that 1 is less than x is less than or equal to 4. Fairly straightforward question this. We can't be equal to 1 because it's a strict inequality, but we can be equal to 2 or 3 or 4. So since these are mutually exclusive events, that means we simply add the probabilities of it being equal to 2, being equal to 3, and being equal to 4, which gives us an answer, once I've written it down, of 0.6. Okay? It's as simple as that. Part B. We want to determine the mean and the variance of x. Now remember that the mean is actually the expectation. So to calculate the expectation of x, what we need to do is we need to multiply each value by the probability of that value, for example 1 times 0.3, and sum them up. So we have 1 times 0.3 plus 2 times 0.1 plus 3 times 0.3 plus 4 times 0.2 plus 5 times 0.1. Now it is a bit of a long statement to write out, but this is what's expected. This is what's going to get you your marks. This is the definition of the expectation of x. So remember, just to demonstrate your substitution into that definition. Okay. At this point, once you've actually demonstrated that calculation that we've got here, you can actually just use your calculator, type it all in one go carefully. No more working is necessary. You just need to then give your answer, which comes out as 2.1. Okay. Now, in order to calculate the variance of x, we need to first find the expectation of x squared. So if we go over, expectation of x squared is almost identical to the expectation of x. What we need to do though, in this case, is we are going to square the x values. So that is the actual values that the discrete random variable can take, not the probability. Okay, so we get 1 squared times 0.3. We get 2 squared times 0.1. And what we're essentially doing, if you do it close together, is you can just copy out the above line carefully, as long as you've made no mistakes on the previous line. And all I'm doing is I'm rewriting it, squaring that x value. So 3 squared, 4 squared, and then finally we get up to 5 squared times 0.1. Now again, once you've demonstrated that substitution, once you've demonstrated the actual series, that is your working mark. So now at this point you can just use your calculator and you can just type it in one go. No more working is necessary to evaluate and get an answer of 9.1. Okay, so at this point we can now calculate the variance of x. Remember that the variance of x is given as, and it's a little bit of a mouthful, it doesn't really make sense when you just say it out loud, so it is a visual thing as well. It's the expectation of x squared. Okay, so that's that last line we just worked out. Take away the expectation squared of x. So that is the last answer, 9.1. So this is equal to 9.1 minus 2.7 squared. Okay, and when you do that on your calculator, you get an answer of 1.81. And so there we have expectation of x and the variance of x. Not particularly difficult conceptually, but perhaps a little bit laborious because there's a little bit of writing to do with it. Just take your time, make sure that you write things out fully and get your marks where you need to. Okay, so part C. Part C is a little longer than other exam questions usually are, but it's no different to any other question involving the independent observations of a discrete random variable. We have three independent observations, x1, x2 and x3, and they are taken from this distribution of x. We're saying, okay, let s, some variable s, equal the sum of three independent observations, x1, x2 and x3, and we want to calculate the probability that s equals 4. So in other words, we want to think about ways that we can have three observations that sum to give us 4. So for example, what we're saying here is a probability. Let's say for example, x1 equals 1, intersect, because we're saying and, x2 equals 1, intersect x3. Well, at this point, if I add up x1 and x2, I get 2, so then x3 equals 2. And although it might seem tricky at first, the only way we can actually make up 4 from 3 observations from discrete random variables up here is by adding 1 together twice and 2. So all we have to think about is the different ways, the different orders that we can actually add 1 plus 1 plus 2 in order to get an answer of s equal to 4. So probability x1 and x2, x1 is 0.3. These are independent observations, so remember we can just multiply their probabilities, so that's 0.3 times 0.3, and then x3 equals 2 is then times by 0.1, which equals 0.009. Now, actually, you've done most of the hard work by this point, believe it or not. All we have to do is just demonstrate and make sure we don't miss out any combination or any particular order of reordering of these observations. So I could do it again. This time I'm going to say x1 is equal to 1. So it doesn't seem like it's changed at the moment, but this time I'm going to say that we get a 2 on the second observation. And so that means that x3 must be equal to 1. Now what's going to happen in this case is I'm going to get 0.3 times 0.1 times 0.3. So actually the probability is exactly the same. All we're doing is we just have to acknowledge that there is a different order for this to be observed in. And the same again, this time I'll observe the 2 first. Okay, so x2 would then be equal to 1, x3 would be equal to 1, and again the probability is exactly the same because I'm still multiplying the same probabilities together. It's just that they come in a different order. Can I observe these observations in any other way? Well, no, because 2 has been observed third, second, and first. So these are all the possible ways that I could get a value of s equals to 4. So then the probability s equals 4. Because these are independent these are mutually exclusive observations. They can't happen at the same time. I can't have 3 observations where I observe a 1, and a 2 at the same time as I observe a 1, a 2 and a 1. They are completely and utterly exclusive from each other. So all it means is I then add the probabilities together. And remember at this point it's a little bit like doing tree diagrams. It's a little bit like the and or rule, because when we do tree diagrams and we find out those probabilities, we're looking at the combination of independent events and then looking at combinations of the mutually exclusive events. So when I add these together, I get 0.027. And so we have answered the question that probability S is equal to 4. Okay, so make sure you try and use a notation or something that is going to communicate effectively what it is you're trying to do, and make sure you show as much working out as possible. Okay, now part 2 asks us to find a probability that s is less than or equal to 4. Now the nice thing for part 2 is we've actually already got the probability that s is equal to 4. So all I have to do really is work out the probability that s is less than 4. Now, the only way s can be less than 4 is if we have s equal to 3. So this means we have the probability, and there's only one way this can happen. That's if your first observation is 1, intersect with your second observation being equal to 1, intersect to your third observation being equal to 1. And of course, there's no other way that you can observe this pattern of numbers because they are all the same. So what I'm doing is I'm just saying 0.3, apologies, that should be 0.3. So it should be 0.3. One second, just having problems with my rubber here. Okay, so it should be 0.3 times 0.3 times 0.3. One second, if you just hold on, please. Which is the same as 0.3 cubed. And when you actually evaluate that, 0.027. So when we have the probability s is less than or equal to 4, what this is actually going to be is this is going to be the probability that s is less than 4 plus the probability that s is equal to 4. So 0.027 plus 0.027, which gives us an answer of 0.054. And that is the final answer. Now, what we can do at this point is we're just going to have a quick look at where do you get the marks during this piece of homework. So looking back at question 1, question 1 is a 1-mark question. So quite simply, you're going to get 1 mark for evaluating and getting this answer here that x probability that x lies between 1 and 4 is 0.6. In part B, determine the mean and variance of x. Well, your first mark here is given for showing your correct line of marking. No other variations of this, it is simply showing the sum of the x value times the probability in full. A second mark is then given for getting the correct answer, 2.7. Okay, next, just like the expectation of x, you can have 1 mark if you've shown the correct line of working to find the expectation of x squared. And just like with the expectation of x, you can have 1 mark for an accurate answer of 9.1 for the expectation of x squared. Finally, your 5th mark comes from actually just evaluating and getting this value for variance of x being 1.81. Okay, so it's 1 mark for the lines of working for expectation of x and expectation of x, and then 1 mark each for each of the correct answers, e of x squared, and variance of x. Okay, so in part C, there were 2 marks awarded for the correct working and evaluation of these 3 probabilities here for x1, the combinations of observations and the probabilities calculated. There is then 1 mark for actually successfully calculating the total probability for s equal to 4 as being equal to 0.027. Then, in the second part of the question, there was 1 mark for identifying that the probability of s less than or equal to 4 was a combination of these 2, so the probability of s less than 4 plus the probability of s equal to 4. There's 1 mark given for actually calculating the probability that s is less than 4 is 0.027, and 1 mark then awarded for actually the final answer of finding that s is less than or equal to 4, combining to give you a total marks of 12 on this question, which is just over 15% in the exam. Okay, hope that all made sense.